Hello, YouTube. This is UML03. In the previous lesson, we brought up a concept called pass by value, and we said that Python and other programming languages pass information into functions by copying their values into the method rather than sticking in the actual identity or reference to the actual variable. Okay, and this can lead to some unexpected results. Remember, in the previous video, we tried using a static method, a standalone function, to increment the value of an int variable, and it didn't seem like it was successful in doing that. And we talked about three approaches to getting around that. So what we can do in this video is review some of what we've talked about in recent lessons, right? JSON and frozen dictionaries and hexadecimal numbers, CHR of X, ort of X, the zip function, and pass by value, and then also review iterators. And I think that that's going to be sort of the focus of these last two lessons. So remember, you have to remember that there are four ways to import a function f from a module m. And at the beginning of the curriculum, we said you can just import the module. So you could just say import m, and then you could just call m.f. Okay, so that's how you could use the function f from the module m, is you could just import the whole module and then call m.f. You could also say from m import f, so that would just import that particular function, in which case you would only need to call f within your program rather than m.f. So hopefully that's clear to you. But then you could also say from m import f as x, and then you could just refer to the function f, which you imported from m, as x within your program. So you would just call x. And then in a much more recent video in lesson 65, we brought up how you could also say import m as y. So that would be importing the module under a different name, in which case you would call y.f. So hopefully that's clear to you. But JSON is a string representation of Python objects such as dictionaries. So if you said something like from JSON, import loads as L, dumps as D. So this would be using the third approach for importing those two functions, right? And then in which case you would call L of X to accept a string X and return a dictionary or like some Python object that would be usable, or D of X, which would accept one of those Python usable objects and return a JSON string representation of it. So hopefully you can go back to previous videos if any of that is still unclear. But frozen dictionaries are a collection of key value pairs which is immutable, so no adding, removing, or changing key value pairs. And in lesson 67, we built a class to define the length of a frozen dictionary. We define what it means to see if an element is in a frozen dictionary. We define what it means to say f of y, where f is a frozen dictionary and y is an element and y is enclosed in square brackets, right? That will be implemented in the get item magic method. Just like you can pass in keys with square brackets into a regular dictionary, we can define how to do that for a frozen dictionary. And we could also define what it means to add two instances of our frozen dictionary class together. What does it mean to add two frozen dictionaries together? So we have a class frozen dictionary and then a constructor in it of me with my dictionary. But remember, me here is not an input. It's not an argument to the constructor. It simply is a symbol to Python that this is an instance method. But here it would just accept one input. So it seems like it says me.dictionary equals my dictionary. So we said we can implement or define a frozen dictionary based on a regular dictionary. And so basically it seems like it assigns a regular dictionary instance variable to the my dictionary parameter that we passed into the constructor. That's what happens here. And then you can define length of a frozen dictionary, just defined by the length of the dictionary which implements the frozen dictionary. So that's a pretty straightforward method there. And then you could also define f of y, right, where f is some frozen dictionary and then y is an element enclosed in square brackets, right? The way that you would do that is to implement the get item magic method. We talked about that in like lesson 37, I think. But then if you say if y in x.dictionary.keys, so you would check to see whether or not y is one of the keys in the dictionary that implements your instance of the frozen dictionary class, in which case it does, right? If that is one of the keys, then you could just say return x.dictionary of y. So you could use like this square bracket notation, but now you're just plucking it out of the regular dictionary on which the frozen dictionary is based. But then if you didn't see that key, if you didn't see that element that the user passed in within your frozen dictionary or within the dictionary on which the frozen dictionary is based, then you could say return and then whatever the element is that they tried passing in, but concatenated with is not in the frozen dictionary, right? You would say, oh, that key, I couldn't find it in the frozen dictionary. So hopefully that's clear to you. And then you can also have a get method, right? So like we said with regular dictionaries, you could say either f of y or f.get of y, right? Where y is a potential key in your dictionary. Same thing with our frozen dictionary class, right? You could either call f.get of y or f of y, but this defines f.get of y by f of y, where we defined f of y in this get item magic method that we just talked about. But it's two ways of accessing a value by specifying a key, right? Either square brackets or calling the get method. But then you could also have a set item method. Remember, in frozen dictionaries, we said that you can't add or remove or change key value pairs, right? So this would attempt to define f of y equals z, where y is one of the keys in the frozen dictionary, or maybe it's not a key yet. Maybe it would be like a new key, but the point is that you're not allowed to add or remove or change key value pairs. So what you would do is if you tried seeing, if the programmer tried running a line of code like this, f of y equals z, or like, f of 3 equals 12, right? But giving a key value pair into a frozen dictionary, you could ask the user, you could say, input frozen dictionary cannot set, right? You can't set key value pairs. And then so it asks you if you want to continue. But the point is that if the user specifies, yes, I'd like to continue, then you just pass. So you just go to the end of the method, right? We just ignore, oh, they tried changing one of the key value pairs. We're just going to tell them that they can't do that. And then do they want to continue with the program? Yes or no. So if they say yes, then that's fine. It's whatever. We just ignore that because we couldn't update the frozen dictionary. So we just tell them that and they say, okay, that's fine. We'll proceed. But otherwise, if they say anything other than capital Y or lowercase y, we could raise an exception, right? We could raise a disruption in the flow of our code and we could just cut it off. And we could say, sorry, frozen dictionaries cannot change values. So they either need to sort of accept the rules on that, or you could interrupt the program. But that's how the set item magic method works, right? And you might not decide to not even write this. Maybe you wouldn't even specify set item magic method. And then if the user tried adding a key value pair, then Python would just throw an exception anyway. But it's up to you how you want to handle something like that. In a string representation of your frozen dictionary, right? So you could say this frozen dictionary is concatenated with the string representation of the dictionary on which that frozen dictionary is based, right? So you could just say this frozen dictionary is, and then concatenated with the string representation of the dictionary on which the frozen dictionary is based, right? So for example, like we haven't even talked about the code that we wrote yet, but this will be an example, right? This frozen dictionary is, and then the dictionary which implements it. And then you can see the contains magic method, right? So that allows you to define element in F for some element in some frozen dictionary F. And then that would just check to see whether or not that element is contained within the dictionary that implements the frozen dictionary. So that's the code in lines 49 and 50. And then we could, so the contains magic method, we've talked about that, I think in like lesson 59, 60, 61, and a fair amount since then as well. And then we can define what it means to add two instances of a frozen dictionary together. So this defines F plus Y for two frozen dictionaries, F and Y. And so what you could do is you could say my dictionary equals me.dictionary. So it's just going to basically harness all the key value pairs from the dictionary on which your current frozen dictionary instance is based. And then you can have a for loop to add the key value pairs from this other dictionary that you'll be passing into the add method, right? Like you get all the key value pairs from F with line 53, but then in lines 54 and 55, you need to add all the key value pairs from Y. And then what you do is you're going to finally return a new instance of your frozen dictionary class, but it's going to be based on this my dictionary variable, which you've been building up in lessons 53 and 55 by combining all the key value pairs from frozen dictionary F with all the key value pairs from frozen dictionary Y. And then we have an instance method called F, and it looks like F of X, right? It looks like it accepts an input, but again, since this is within a class, X is just a symbol to Python that this is an instance method. So like for a particular instance I, you would call I.F. You wouldn't call I.F of 2 because X is not an input here. There's no inputs, but you call it on an instance, and it just happens to return 8. And then we have a subclass, so class callable frozen dictionary of frozen dictionary. So it's a class that inherits all the methods and functionality from the frozen dictionary class and has its own constructor though. So the way that the callable frozen dictionary constructor works is it calls the superclasses constructor. So the regular frozen dictionaries constructor, which remember, if you scroll up, what does the regular frozen dictionaries constructor do? It assigns the dictionary instance variable to the regular dictionary, which is passed into the constructor. But the callable frozen dictionary would do the same thing, but it would also print the statement on line 67. It would say this one is callable. So hopefully that's clear to you. But then we also have an F, right? So we talked about this F, right? But it's not F of X or F of Y, really. There's no inputs to this F. It just indicates to Python that it's an instance method. But the way that it works is it calls the superclasses F method and raises it to the power of 2, but gives the floating point representation of it. So what would be 8 to the power of 2.0? Well, that would be 64.0, because we said in lesson 2 that with implicit casting, right? Like if you raise a floating point number to an integer, or if you raise an integer to a floating point number, you end up with a floating point number. So this was the result of calling f on an instance of the callable frozen dictionary class will be 64.0 because the floating point representation of 8 squared is 64.0. And then we have a call magic method, right? So we've talked in previous videos about how you can treat an instance of a class as though it were a function that you could pass in inputs to, right? So this U here is not an input. U indicates to Python that the call magic method is an instance method, right? And then you have a star S. So like in lesson 44 or 45, we talked about positional arguments, right? And the idea that if you have this asterisk before your input, basically what it does is it allows you to pass in an arbitrary number of inputs to your function, and it treats all those inputs as though they were coming in as a tuple. So if you didn't pass any inputs into your call magic method, right, if you just called it on an instance of a class, well, then the length of that implied tuple would be 0, in which case your call magic method would return false. But if you stick in any inputs when you call the call magic method, right, if length of s is greater than 0, then this call magic method would return true. So hopefully that's clear to you. So what we're going to do on line 90, right? So we can start running this code on line 90. We create a simple set with 6 strings in it. That's not too bad. And then on line 91, we're going to create an empty dictionary. So we're going to say regular dictionary equals dict. And then in lines 93 and 94, we're going to add key value pairs to the dictionary. And we're going to take the strings from the set, which was defined on line 90, and we're going to basically associate each of those strings with values. And those values are going to be the length of each of those strings. So you're going to say regular dictionary of P equals length of eval of P, right? Because eval, remember, eval accepts a string and it returns like the actual Python evaluation of that. So it wouldn't be the string P, it would actually be the variable P, right? So what would length of P be? Well, that would depend on the string that you're currently at, right? Like it could either be 3 or it could be 6 or it could be 4, right? But it depends on the current string that you're looking at. But the point is that regular dictionary will be generated as a regular dictionary where you have these 6 keys as strings, and then the corresponding values would just be the length of each string. And you can see like summer and update, those have the same length because we said the keys in a dictionary have to be unique, but the values in a dictionary don't have to be unique. So update and summer would both have a value of 6, which is fine. And then what we're going to do is talk about a constructor reference variable. So remember in lesson 15 and a couple times since then, we've talked about how basically if you have a function f of x, and then you say something like w equals f, what that immediately does is it creates another function called w of x, which works the exact same way as f of x. And the point is that this sort of approach extends to constructors as well. What you really have to drive home here is that a constructor is a type of function. So let's say you have a class C with a defined constructor C of xy, dot, 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 right? X and Y are just arbitrary labels for the parameters that the constructor accepts, right? But A and B, dot, 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 could be sample values of X and Y, right? So maybe X is name and Y is age, for example, and you're talking about a person class, right? Well, then A could be Abby, like an example of a name, and B could be 26, an example of an age, right? But then what you can do is you can write something like D equals C. So this would be a function reference variable, but more specifically, it would be an alias for the constructor C. So call that a constructor reference variable. Then you can skip down to line 87. Then you may write W equals C of A, B, dot, 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 right? Because we said A and B are like sample values for the constructor to pass in, right? So you could either just call the constructor C, right? This is what we did, W equals C of A, B, dot, 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 right? Call the normal constructor with some sample values. Or by writing on line 82, if you say D equals C, right? If you come up with a constructor reference variable, then you can call W equals D of A, B, dot, 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 right? So it's just creating another label or alias or just another name or nomenclature for referring to the constructor in the exact same way, but it's an example of a constructor reference variable. So what we do here, remember we have this regular dictionary with the 6 key value pairs in it, and then we're going to say FD equals frozen dictionary. So this creates a constructor reference variable for the frozen dictionary constructor, right? Because frozen dictionary, it's kind of like a method. More specifically, it's a constructor, but the point is that you can create an alias for it. And then now what you can do is you create an instance of the frozen dictionary dictionary class, but instead of needing to write frozen dictionary, you can just call FD, because on line 97, you set up that constructor reference variable. So on line 98, you say frozen pizza equals FD of regular dictionary. So it creates a frozen dictionary based on the regular dictionary, which was generated from lines 90 through 94. And then on line 101, so now we're going to start running the code, print length of frozen pizza. Well, that would test the length magic method that we talked about earlier, right? We said we define a length of a frozen dictionary based on the length of the dictionary, which implements the frozen dictionary, right? So if you say length of frozen pizza, that would be 6. That works as it should. And then print frozen pizza. Well, that would test the str magic method, right? That would be the string representation of your instance of the class. And we said that was going to print this frozen dictionary is concatenated with the string representation of the dictionary which implements the frozen dictionary. So that would be this frozen dictionary is, and then, sun 3, summer 6, open 4, update 6, table 5, can 3. And then you could say print frozen pizza of table, and that will give you 5, right? So that tests the get item magic method, the idea that you could pass in an element within square brackets, but that's what get item allows you to do. And then you could say print frozen pizza dot get of op concatenated with en, right? So that would be testing your get magic method, and that would return 4 because that's the value associated with the key open. And then exec. So remember, exec of x accepts a string x and executes it as Python code. So if you say exec of print of sun and frozen pizza, or print sun and frozen pizza is all in a string, then that's just the same thing as saying print sun and frozen pizza. So it's sun in our frozen dictionary. So that will be testing your contains magic method. And the answer is true, right? Because it turns out that sun is in the dictionary, which implements the frozen dictionary, right? It was one of the keys. In fact, it was the very first key. So we would say it is in our frozen dictionary because it was in the regular dictionary, which implemented the frozen dictionary. But then if you say exec of print of 3 in frozen pizza, that will be false, because the point is that dictionaries and now frozen dictionaries by the same token, if you check to see whether an element is in them by default, we think you're looking through the keys, right? Not through the values. So it doesn't matter if 3 is a value in the frozen dictionary. The point is that 3 is not a key. So the result will be false for this call to the contains magic method. And then if you say frozen pizza of thunder equals length of thunder, well, this is where you get an issue, right? So then this is where we're going to instruct the program to say, frozen dictionary cannot set continue, right? And so if you enter anything other than y or y, right? If you enter anything other than, yeah, I want to continue, then we said, okay, throw an attribute error, because we want to tell the programmer that you're not allowed to add key value pairs to a dictionary. But let's say that we had done y here instead. So let's say that we're going to continue. So that's fine. So that's the end of that line. And then now we're going to go down here, right? So T1, so it creates a regular dictionary with 4 key value pairs. All the keys are 200, 300, 400, and 500, but the value is all 200 because we said the keys in a dictionary have to be unique, but not the values, right? And then we're going to use our constructor reference variable, which we talked about a few minutes ago and created on lines 97 and 98 to create another instance of our frozen dictionary class based on T1. So it's going to create T2, a frozen dictionary, based on T1, a regular dictionary. And then what it's going to do is it's going to say length of combined frozen dictionary. And this is going to test our add magic method, because what it does, see, it has the plus sign here, but these are not like 2 integers or floats or even strings. These are 2 arbitrary instances of any class. And so you define what it means to add 2 instances of any class together with the add magic method, like we talked about in lesson 36. So if you wanted the string representation of the length of the combined frozen dictionary, like the frozen dictionary that will be yielded if you combined all the key value pairs from frozen pizza with all the key value pairs from T2, you would get 10. So it says length of combined frozen dictionary 10. And then you say T3 equals 5, 2. So it's just a simple regular dictionary with 1 key value pair. But this time we're going to create an instance of our callable frozen dictionary class. Remember, that's the subclass of the frozen dictionary class, with the only distinction between the two really being that the frozen dictionary is not callable, whereas the callable frozen dictionary is callable because we specified a call magic method. So if you say y equals lambda tz, it's a lambda function that accepts 2 inputs, and it just returns whether or not the first input is callable. So disregard the second input, it doesn't matter. But if you say print y of T2 with 100, well, remember T2 was an instance of the regular frozen dictionary class, which is not callable. And so then that would be false, right? That's the false that you get printed right here. That would be false here. Okay, so hopefully that's clear to you. But then if you say print y of t4 was 700, well, remember t4 is an instance of a callable class. And so that's why you get true here printed on the console, because t2 would not be callable, but t4 would be callable, right? And then if you say print what, and then let's print the result of t4 with no input. So if you print the result of treating this instance of a class as though a function, right? T4 with parentheses, you look at the call magic method, and here this would be an empty tuple, so it wouldn't accept any arguments, so it would return false. So we can go ahead and review some of that stuff in the next video. From Mimosa3, thanks for watching, and please subscribe.